So lesson 6.3, summation notation, and the definite integral notation. So so the area under a curve from A to B will equal to the sum of an infinite amount of rectangles. So what I said earlier was that both the integral and the derivative depend on the limit. As the number of rectangles goes to infinity, the sum of adding up all these rectangles from I equal to, from the first rectangle to the nth, it's infinity. My infinity sign's a little messed up. So the limit as n approaches infinity of the sum of these rectangles, which will equal to f of x I times the change in x where change in x is equal to the width of the rectangle in any case, yes, the width of the rectangle, change in x, will equal to, from A to B, we're going to split it, or B minus A, into this n number of rectangles where n approaches infinity, B minus A. What else? xi will equal to wherever you started at A. So if we start here, it'll be the lower bound, the left one, A plus that change in x. Let's see. All right, here. Limit as n approaches infinity, I equals 1 to f of xi, change in x. That took a long time to get to that point. Up until then, it got 300 years ago, 400 years ago. They said that that equals to the integral from A to B of f of x dx. That's modern calculus here. That's where I change in x. I knew it. I had messed. This is so important right here. The lower bound plus I change in x, I change in x, I. change in x is b minus a over n. All right, let's do two problems, and that is it. Problem two. What? It's supposed to be problem one. Yeah, that's what I was doing right now. I was like getting rid of some things. It's problem one. I had a problem. I took it out. Write the definite integral that is equivalent to the limit as n approaches infinity. Da, 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 da. I don't know about I equal to x. What the? It's 1. What the heck? I equal to 1 to n. What the heck? Okay. So we want to go from that to something like this. From a to b, f of x dx. Okay. What is A? What is A? This number will be A. It's starting there. For whatever ln function is. Maybe you got some ln function going like this, and we are starting at 1 and going that way. So from A to A2, so it'll be what? From 1 to what? What do you think? We're going from A equal to 1, no? And then the width that we're going to cut it into n rectangles is 2. From A to B is 2. 1, 2, no. So this, but if A is 1, this is 1, then what is B? Because the width is 2, see? The width from here to here. And we're trying to find what this is. Maybe? What number is this? 3. So basically we're going to go 1 plus 2. So from A and then add that on top of n. So that would be 3. ln x dx. With the worksheet, I hope that you just see patterns in how to get these things. That's how you probably get tested on the AP. They'll tell you write the definite integral of this, and they'll give you multiple choice answers. And then this hopefully will be one of them, like this. Let's see. Problem 2. And we're done today. This is it. Problem number 2. write a right Riemann sum for this integral? Okay. This definitely will have to be in there. The limit as what? N goes to infinity. N goes to infinity of the sum I equal to 1 to n. What was that change in x? Change in x is what? What did we say change in x was? What's the formula? B minus a divided by? Huh? N? So what's b minus a? Well, isn't this ab? So it'll be 3 over n. I'm doing this second part, the width, and then we'll do the height. I'll put it here. So it should be 3 over n. That's the width thing. The height will be because you multiply the width times the height. We gotta get that starting point. See, what did it say? What did it say it was? What was that formula about xi? It wasn't, It was xi is what?
A plus change of I change of x.
I times change of x?
Yeah.
A plus I change in x. So A is what? 4 plus 4 plus I. And what is changing x is 3 over n, no? Oh, it's 3i n, no? Over n. Did I mess up? What was it? Did I put it on the square root? I think I messed up there. So x is gonna be what? It'll be. We did get this part. I didn't put the square root of it. No, square root under it. Because it's square root, no. That's kind of like the idea of it. And that's it. We're done.